This is a continuation of our lesson on ratio and proportion. Here we'll go over one more example on applications of ratio and proportion from chemistry. Let's take a look. So once again, we're given a chemical equation, and this one has already been balanced. That means the given coefficients in front of each of the terms are what they're supposed to be. In your typical chemistry classes, you may actually be asked to figure out what the coefficients are going to be, that you may get blanks before the expressions, and those are your coefficients, and you may be asked to do that. So here we're actually providing you with the actual completed equation with the correct coefficients, but our job will be to determine in part A of this question, if we are given 6.0 moles of NH3, then how many moles of oxygen will be needed to react with that quantity, and how many moles of NO or nitrogen monoxide will be produced, and how many moles of H2O or water will be produced. So let's begin with the first part of the question, the first question mark right here. And at the moment, don't worry about the second line here. That will be our second question. So 6.0 moles of NH3 is given. The question is how many moles of oxygen will be needed to react with that based on the given equation. And what we learned in the first section of the video was that these coefficients gives you, the coefficients give you the proper ratio of how things should be. Like the ratio of NH3 to O2 should always be in the 4:5 ratio. And same thing goes here. So the ratio should always be, and I extracted those numbers and put them on the top of our table. The ratio should always be 4:5 to 4:6. Those are the proper ratios of how these quantities, how these substances are going to react with each other. And they're going to produce these quantities at the given amounts. And one thing to pay attention here is these numbers represent moles of that quantity. And you'll learn more about the mole unit in chemistry at the moment. Let's just say that these coefficients must be in terms of moles. Okay, so since we're given 6.0 moles of NH3, our job is to determine number of moles of oxygen, and we know that this ratio must hold true, the ratio of 4 units of the first quantity to 5 units of the second quantity. So if it's 4:5 ratio, it will be 6 to what? That's the question. That's the ratio and proportion question we're dealing with here. And first, I'm going to solve this with the equation method, and then with the chemistry conversion method. So let's begin. I've already set it up over here. So the standard units conversion was 4 moles of NH3 to 5 moles of O2. So I wrote it down, 4 moles of NH3 to 5 moles of O2. That must be equal to, we're given 6 moles, 6.0 moles of NH3. So I put that on the top. Again, if you have the NH3 on the top, your moles of NH3 should also be on the top in your second fraction over here. And the unknown, X moles of O2. That's the unknown. And again, if you have O2 on the bottom, then your X moles of O2 should also be on the bottom of the second fraction. Now that we have all the units matching on the top, matching on the bottom, at the moment I'm going to ignore the units and just solve this as a simple equation. Remember the cross multiply method, the product of this times that will be equal to product of this times that. So we're going to cross multiply. So 4 times x, again ignoring the units at the moment, equals 6.0 times 5. And to solve for x, since it's being multiplied by 4, divide both sides by 4. So x will be 6.0 multiplied by 5 divided by 4. And here we're getting 30 divided by 4, and the answer is 7.5. And we're going to leave this with two significant figures because the given measured quantity was given to us in two significant figures. And you can assume that the constants that are given in the equation are exact and that they're not going to reduce further your number of significant figures. So you should only be concerned about the given measured quantities for this question. And if you haven't yet learned about significant figures, just don't worry about that. Just pay attention to the how we set up the ratio proportion part of the question. Okay, same question. How many moles of oxygen will be needed to react with 6 moles of ammonia or NH3? So, but this time I'm going to solve it with the other approach. So the question is how many moles of O2 given we have 6 moles of NH3. So here I'm going to need to write down a conversion factor. And what would you write on the top and what would you write on the bottom? Basically, you want to cancel the NH3, so you should have NH3 on the bottom. And you want to be left with O2, so you should have moles of O2 on the top. And this comes from your given equation. So the relationship between O2 and NH3 are 4 to 5 ratio, 4 NH3 to 5 O2. And the NH3 part of that will go on the bottom. So here I've already written that out. So 4 moles of NH3 we know will react with 5 moles of oxygen. That's based on the given information. 4 moles of NH2 will react with 5 moles of O2. And now cancel away the units from the top and the bottom if they match. And then we have the answer. So just multiply the constants. 6.0 times 5 divided by 4. And the remaining units will be your moles of oxygen. And notice that we're getting the same exact answer as we got earlier, which is 7.5 moles of O2. Okay, so we can fill in the first unknown with 7.5. Let's move on to the second unknown. Now for the second unknown, how many moles of nitrogen monoxide or moles of NO is what we're trying to figure out. If you look at the given ratios, they react as 4 to 4. So we really don't have much work to do there. If this is 6.0, it's like a 1-to-1 ratio, right? Whatever the first one is, the third one is the same. So that should also be 6.0. So we don't have to do any work for that one. 4 to 4 ratio, same as 6 to 6 ratio, so they'll be exactly the same. So let's figure out the last one then. How many moles of water will be produced, assuming you have 6.0 moles of ammonia, NH3, given to you? So how many moles of water will be produced? And the ratio there was 4 to 6 ratio. 4 moles of NH3 to 6 moles of H2O based on the given equation. So let's begin with what we want to find out. So we want to determine number of moles of H2O, so I wrote that on the left-hand side of our equation. And then I also wrote down what is given to us, which was 6.0 moles of NH3. And then the conversion factor. And the conversion factor based on the given equation was 6 moles of H2O with 4 moles of NH3. And which one of those would you put on the top, which on the bottom? Well, we want the NH3s to cancel, right? So we're going to put 4 moles of NH3 on the bottom. And again, that reacts with or produces 6 moles of water. So 6 moles of H2O goes on the top. Again, these came from the given equation. And now cancel the similar units. So moles of NH3 from the top can be canceled with moles of NH3 from the bottom, and that will give us our answer. So the answer is 6 times 6 over 4. And that will be 36 over 4 or 9, but once again we're going to leave our answers in the given number of significant figures. In this case it was 6.0 was given, so we'll leave our answer as 9.0 moles of water will be produced. So what I'd like for you to do right now is, would you please fill in the blanks for the second row? Given that 15 moles of water has been produced, can you find out how many moles of ammonia will need to be used, how many moles of oxygen need to be used, and also how many moles of nitrogen monoxide or NO will be produced? So figure out the results for each of these question marks. And that one I've already prepared a solution. So please pause the video, and when you come back, you will see the answers listed. And here's a solution for the second one. I'll leave it on the screen for you guys to go through this one. And in case you didn't get the right answers, go through the steps. And there you have it, another example on the application of ratio and proportion.